Hello, people. Do you see this face? This is a happy face. This is a happy face. Bit tired, but still, this is a happy face. This is like the face you have when you're like satisfied in life. This is like life happiness face. It's like quiet, it's calm, but happiness is like, it's on the inside. It's not out here, it's not a crazy waving you around your arms. It's like calm and like controlled, like, so satisfying. Okay. I've gotten an electronics desk. I've switched positions, but I've gotten an electronics desk, which has been nice. I have not been able to control myself, because now I can do electronics all the time, because this is like a foldable table, and just fold it out, do all my electronics, and then pack them up afterwards. And this can stay folded up throughout the day, no worries. This is like a new space in our apartment, so I can do a lot of electronics. And I'm sorry, I've been doing so much electronics, and I haven't been able to show you a video about my new components because I've used them in practical applications, and I will show them to you. But just to let you know, this is a happy face. This is like joy on the inside. It's like life-giving joy on the inside. It's so satisfying. Okay, what I have built, I've already told you about, but the result has become great. It's like so good. Can you see this? Can you see this? This is a 230 volt socket. This is a piece I took off the cable that I put on my new power bank. It's so glorious. I'm gonna fetch it for you. Here it is. And I'm telling you, it's so nice. Okay, what this is, we have talked about it earlier a bit, not like a lot, but like a bit. This is my 30 cells, 18650. They have been connected in parallel with this method that I've also told you about. A big piece of copper underneath this black plastic. A big piece of copper runs the entire perimeter, and each cell is connected to the copper. So these two are connected to the copper over here, and this one is connected all the way. They are like connected. So if a short circuit happens anywhere, the wire will burn, and it's all great. So you can scale it up. You can make like huge cells. And my delivery of my 100 lithium-ion batteries for, it's over $100. No, it's over $500. It's right here. But I don't have the proper, the black plastic stuff that keeps all this in space. I'm not like gonna do like crazy unpacking on this before I have, before I have the black plastic to wrap it in. Don't worry, I will unpack it in just a moment. But so this is one big cell, parallel cell, safe, because if there's a short circuit, it will just burn off the connection, and the battery will disconnect, and everything will run fine with fewer cells. Okay, so what this is that we have this power cord, which is like, yes, Europe assists. This is a European socket or jack, or whatever you call it, a plug, European plug. So this one goes into the wall. It goes through this, into this piece of electronics. It's a module. I bought it like this. So you have, I think I will explain to you in detail how this module works. But for now, all you need to know is that alternating 230 volt power comes in here, and at the other end out comes 24 volts up to 6 or 8 amps. I haven't tested it yet. That runs into this secondary module to do the secondary step down. Also to have like a bit of a division between, like, this one touches like a big power plants with this wire, and this one only touches this. So it's like kind of a safety thing, but still it's like this one takes the big step down to 24, and then this takes it from 24 to whatever the cells are, like 3.5 volts. So 24 comes into here. This is adjustable by underneath here. There are some adjustable screws. I will tell you more about them later. I cannot do it today. And out comes whatever the battery needs. So this one is connected to this 3 terminal. This is like a big industrial 40 amp 12 volt 40 amp switch, which has like 2 settings, like one setting and 2 setting, and then the middle one. So it has like 3 terminals. So one of the terminals comes from this charger, big charger, and the middle one is connected directly, hardwired to the positive back at this end. It's like run through this wire. And then the last one is connected to my actual output, which is this quite tiny module, and it was in the delivery that I would have spoken to you about in between, but because I've been like excited about my new workspace and my new components, I've just put it on before telling you about it. But it's like a tiny, it's like a small USB-A type socket, like a small PCB, and then a tiny amount of components, the same amount but arranged in a tiny way. And then this micro USB. So this one discharges it, and this one charges it. But it's like in a tiny package, and you can see the coil underneath, maybe. But yeah, that's like the coil. It's very tiny. It's nice, and it can charge my phone, and it's connected correctly with like a resistor and the data pins. So this one will charge my phone. And one of my new components is this piece of electronics. Right here there are like 2 displays. The upper one, red one, voltage. The lower one, amperage. And amperage is nice because I haven't had components to measure amperage directly before. But you can see it on the inside here. You can see that there is the circuitry inside it, so you can just look at it as a normal module. It has 3, you can't really see it, I'm sorry, I would have told you about it before I made this, but I was so excited, I couldn't help myself. But it has like 3 wires, it has a ground, and it has a positive, which has to be between 2.5 volts and like 40 volts. It can take everything in between those two, or maybe like 10 volts, I'm not quite sure, and I haven't tested it because I'm too excited. So it has its own power, and when it has its own power, it has the 3rd wire is like the voltmeter. It can measure wherever on the circuit, and it has 2 huge wires, and those 2 huge wires, they come out of this plug right here, and that is the amp meter. So whatever runs through those 2 wires, it can measure the amps. When you turn this on, you can see that my battery cell has like 3.9. Why is this backwards? Huh, okay. This looks strange on the screen, but it looks correct in real life. I don't know if you can see. That's 3.9. And the 0 amps are running because it isn't charging. And But this is nice. So on this switch, I can like have it on neutral, nothing is connected, the battery is just floating, just if you take a piece of battery and put it on a shelf. And then when you put it to the lower one, the voltage from the battery gets connected to this charge unit up here. I know it's tiny, but it's like this charger can run for 4 days or something like that, constantly charging whatever on this big cell or big unit. So it's like there's only one, and it is tiny, but it can run for like 4 days straight, with all the batteries being in perfect condition. And the second one is when I connect the battery to the charge unit. And whenever it's connected to the charge unit, it also connects to the display, because the display monitors the charge rate. So at the moment, it can see that the battery is 3.9, and there's no amperage running through the charger. So it's exciting. 230 volts AC converts to a lower voltage 24 volts DC. The DC gets through a current adjustment system. This one adjusts the currents, so the voltage never ever gets above 4. And it can, it says on the paper it can take up to 8 amps, but I don't think it's like 4. But we will see. And it goes in through the amp meter, and then we can see the amperage going into the battery. Unfortunately, or how you want to say, this battery is 3.9 volts, and 4 is the maximum. So if we were to put this into the wall to make it charge, it will not draw the maximum amount of amperage, because the batteries are almost full. And when they are almost full, it doesn't draw as much amperage, but it was like low or like middle voltage, it could draw whatever this can deliver. This system actually, these cells can easily take 30 amps. But these circuits can nowhere deliver 30 amps. It's more like 4 or 8 or something about in that scale. And to prove it to you, that I've tested this also, but just to prove to you that this is working, and this unit that I have connected the components to, it draws power directly from the socket. So, as you can see, at the moment it draws 3 amps at 4 volts, 3.19, 3.2 amps. So that is a working, safe battery system or power bank, drawing power directly from 230 volt AC socket, delivering it safely at least 3.5 amps to these batteries. So it's quite nice. It's working. Nothing is like humming or fizzing or doing any crazy stuff all over the place. It's like calm. But if you were to touch these terminals, you will get 230 volts directly into your hand. So it's also a bit more dangerous. But I think some coverage of the most critical areas will be quite easy to do. Yeah. When I first connected this, I measured that whenever it's disconnected, the 230 volts they decrease. So whenever you disconnect it, I had some probes on it with my voltmeter or multimeter, and I could see the voltage going down. So like within a second, the thing or the battery is like discharged, or not the battery, the power electronics handling 230 volts is discharged within a second. And then the 24 volts is a bit behind, but it's like in 8 seconds it's under 2 volts. So this is safe. So yeah, I'm really proud of it. I think it's gorgeous. It's well made. It's yeah, safe, and it draws power directly out of a socket, and it has a really nice big potential, because this system scales very easily, because the technique I've used to interconnect all the batteries. They have like a huge scale, because if ever one battery fails, it will disconnect from the others, and there's no waste running across a transistor or something like that, because some battery systems, they detect low voltage and they will shut off all the power with a big transistor. But whenever the system is working, all the power is going through that transistor. So there's like a waste. Whenever the system is working, there's a waste because it has to run across transistor. So but yep, it's working, and I can tune this last component. I can tune it to run with whatever amperage I want to. So I think previously I've tuned it to like 3 amps, and that's why it's running at like 3.1. It's like a small adjustment thing, so you cannot do it like really precisely. But so that's where all my happiness arises from. That this is done, and it is working, and it's safe, and it went as planned, or however you want to say it. In the beginning, when I made this, I had like 3 revisions of it. Like first, I connected it all up as I thought it should work, and then the amp meter didn't work. And it turns out you cannot just put an amp meter wherever in a circuit. You have to put it next to ground, because the amp meter, whatever the technology is, I'm not quite sure. I have a good idea, but I'm not quite sure. The amp meter has to be to ground, so there are 2 wires on the amp meter, a red one and a black one. And the black one has to be connected to ground. So it's the last instance in the entire circuitry before the power reaches ground. It has to go like into the red wire in the amp meter, through the amp meter, and then directly into ground. Because in the beginning I put the red wire from the amp meter to the positive side, and the black part of the black side of the amp meter I've just put to the charger. But because it was like high, 3 volts on each side, it was it didn't work. It didn't function like that. I had a wrong assumption about the amp meter. But whenever I connected it up and it was to ground, it worked. So that's why whenever you have a circuit like this, like a module with an amp meter, the black side of the amp meter has to touch ground. So that was one thing. And the other thing was that in the beginning, because this is so tiny, this charging thing, because it's so tiny, I thought that it should just always be connected, because now it's like a huge cell, so the small milliamps that this draws is like, it doesn't matter really. It can sit on it for like a month without you can see the voltage dropping. But then again, I have this 3-way switch, which was by accident, because it was just the only like big amperage switch I could find and could find on Amazon, because this, whenever you have like big amperage switches, like big and bulky, and this is flat. It's still big, but it's like flat. But it has 2 settings. So it's like when it's on this setting, it can charge from the wall, and it will show, because there's nothing connected and on the wall side, it will show the voltage of the battery. So this is actually an indicator. So whenever this is not plugged in, this will indicate what the state of my battery is, and this is like full. I consider 4 volts fully charged to keep the condition of the battery great. And then whenever it's on the middle state, it's completely disconnected. So now the batteries are just floating. They're just like disconnected, like if you put a battery and put it on a shelf. And then because I had this top setting, which I didn't use before, I thought like it's like a perfect setup. So when it's like on the top setting, it connects the battery to the charger. So at the moment, this one draws like a milliamp or something to maintain the circuits. So because of that, it's like now I can charge. Now it can be on the shelf and be like in storage forever. And now I can charge it, and if it's not charging, it will indicate the voltage of the cell. So I think this turned out perfect. Switch turned out perfect. The charger is like perfect. The amp meter, I got it running. Had some mistakes, but had it running. I needed to do some other soldering to make it, because in the setup where I put it on the positive side on the circuitry, there was like one wire setup, and because I had to put it on the negative side of the charging setup, I had to reroute some of the wires, but it turned out great. It's quite compact. It's, you can see the wires running, but still I think it's quite compact. You can put it like this when the wire is not around it. You can put it like this and it's like standing. And whenever it's in my closet, you only see like this. You can see like, you can put it like this and you can see how much juice is left on the battery. And when you put it like this, it charges. So really happy. Really like this design. So yeah, but I've received 100 18650 cells, and I think I've peeked in the bag, but I think I will show you the box, the big box. So if you want to see inside, this is what $500 of, or more than $500 of batteries looks like. These are the best 18650 cells that you can buy for money. These are the best. And here are 100. So they're like boxes. Like this is like heavy. This is like 1.5 kilos or something. A kilo, I think. And there are 3 of them. There's like, what's this? This is also, oh, I think I got something for free. Look at this. Ha! I think he sent me this. Like a gift or something. Huh. This is nice. So yeah, it's just a lot of batteries, but I'm as I said, I'm still waiting. I'm still waiting for the sockets or the holder for this, the plastic enclosure. I'm still waiting for that. Still waiting for that before. That's where you place the batteries into when you have connected them. I can show you. So this is one of the circuits I have gotten. I'm going a bit low on light, so I think I'll do this. So this is one of the circuits that I've gotten in my last. I had like the big bag last time, and this has like the USB charging socket. It has the charger for the phone. It has the charger for the battery. It has all the electronics to do both the charging and discharging of the battery. These are the 2 terminals for the battery to connect to this module. And you can see the coil. The coil is like completely a piece of iron. So it's like completely enclosed, because the other systems were like a ferrite material, but this is like actually iron. So quite exciting to see a new type of coil that is of extremely high quality, because it's like completely sealed off and it's like iron. So it's quite nice. So I took one of these circuits and Oh yeah, that's also nice. I'll show the two later. But I took, because it's like a nice module. It has all the parts you need, and there's nothing else you need to put on it. So I took this, and this is like the destroyed circuit from last time, and this still works. I can still tell what the voltage of my battery is. And then I placed this underneath it, and it was only like these two wires, and this switch up here still works. So it has the exact same functionality. Oh, and you do this, then you do this, and then it works. So it has the same functionality as this circuitry up here, but it's all in one module. So that's nice. And yeah, this one is exciting. This beast right here. So I told you about last time. I told you about that when you make power banks where the cells are in series, you have to check the condition of each cell, because if one of them gets like really low, if you only measure the voltage from one end to the other, it's like high, and you cannot see if some cells are high and some cells are low, because if some cells are low and you continue to discharge it, the voltage will drop way below 3 volts, like 1 and even lower, and that will destroy the battery, and then you have like a huge pack with like a destroyed cell in the middle, and you have to take it all apart to change that one cell. So I made like a custom set of voltmeters on like, so because this is like a cell for racing car, like a RC racing car, and then I made this so it has like all the voltages of each cell, so you can see like yeah, what can you see? They're all in quite good condition. They're like in the middle state, which is good for storage. So this is like, you can see the condition of each cell, which is like perfect. And then I made this. So this is an individual charger for each batteries. So these are like interconnected. So each of these cells each of these modules connects directly to a cell. So here in the top I have like two sockets. I have like a socket for the chargers, and I have a socket for the LED voltmeter indicators. So if I change this around, then if I could maybe see before, like, okay, cell number 3 has like a low voltage state or whatever, then I can do like 1, 2, 3. Okay, so like this charger, then I have to charge this. So take some other battery, put a cable in it and stuff it in, and then I can charge the specific cell, which is low voltage. And I can also draw, if one is like very high, I can draw the exactly of the cell. I can draw this out, and this works. Just trust me. But this system works, and I've charged the cells on this with this. So really nice. And it has also it has like these are the same small modules as I put on my big bank, and that's why I knew when I placed it on it, I knew that these could charge my phone, because I've charged my phone directly out of these cells from this module. And this one is yeah, the new modules. So like this is the cell number 1, and then 2, 3, 4, 5, and 6. So that's that. All my pixels, and I have some old modules, and I have some more modules, but I think this will be all for today. I've reconsidered my small power bank I've made. I've put like in a box because it was like falling apart, and I was fearing that something would short circuit or like connect to a piece of metal beside it. So I put it like in a box and roughed it up. So I still have the functionality that it can charge my Bluetooth headset. It still sticks out, so it's still like functioning, but yeah, it kind of fell apart, and I didn't really trust the circuitry to be to hold up. But yeah, and if you want to see my desk, so this is like a folding IKEA desk. You can see it pivots around this point back here. Yeah, it pivots right here. So like this is my soldering setup. Yeah, not actually. This is my soldering setup. This is like my sitting, drawing, figuring out, cutting, making like precise things, taping things together. And here at my bathroom is like my soldering setup. So it's like I have my soldering iron over here. It connects to the wall. All my pieces on like test setups. I had some high energy resistors and USB for a separate power bank to plug it in to test the amp meter. So I tested it at this setup, figured out that it worked. I put it onto my big system, and then it didn't work. And then I backtracked. At my test setup, and at my test setup, it worked, and the ground was connected directly. So yeah, that was why I could backtrack and find out what was wrong with the amp meter. But thank you for today, and have a great time.